Okay. Okay, so this is a quickie talk. I actually have done this as a lightning talk before. Oops, what happened? I got in the wrong... I think I started getting things slides, which is not a good start for a 15-minute talk. So I've actually done this talk in 3 minutes, so let's see if I can do it a little slower this time before. Performance tuning, you're doing it wrong. So this is me thinking that I'm doing it right. So let's just see where it goes. Number 10, no performance requirements. Biggest problem we have running into teams or teams that run into problem is that they simply do not collect any performance requirements, or they're not given any idea, or they have their own ideas of what the performance of the system is. And, ooh, I'm on a timer. Excellent. So I think I'm going to have to, didn't realize that. That's really going to be really fun. Okay, and so the performance isn't given due consideration. These are the teams that we generally find have the most problems with performance when they actually go to deploy. And that usually ends up in a lot of cost overruns. Oh, thank you. The timer is still running. Number 9, tuning by folklore. So basically what I'm saying here is that whenever we performance tune a system, what we're doing is we're reacting to local conditions. And when we actually start acting to local conditions, sorry, I'm going to have to turn off the animation here too, which is going to be really fun. Okay, fantastic. Sorry about that. I forgot I had that turned on. So what we find is that generally you're reacting to some local condition. There's something happening locally in your system that generally doesn't happen elsewhere. And so it's happening in some context. And what we see a lot of... God damn. Sorry. I'm just going to do it this way. Is I thought I got it turned off, but I guess not. What I found is that performance happens in this particular context, so it's a reaction to something happening in your local environment. Now, what happens is that we get all of these, product companies. As we're a product company too, they're going to say like, oh, how much memory does our application need in order to run, or how should we configure our JVM? And they'll ask all these other types of questions. Of course, the answer is it depends. At which point, what do you guys say? Well, how much memory does it need, right? At which point we say, it depends. And you sort of play this game back and forth for a while, and then afterwards you're like, okay, I give up. You need 2 gigs. Minus MX 2 gigs, done, we're good. Box check, go to management, see, got the server configured, off we go. Then it's like out of memory error. Ooh, the vendor was wrong. Okay, So, what we find is that, people use this this information and they try to tune their systems with it, or do this or that and the other thing. And quite often what happens is as the technology stack changes, these things get dragged along from generation to generation, all of these decisions. And no one's looked at them. So just a couple of weeks ago up here north of London, I took a system that was using old configuration parameters and basically improved the performance of it by 50% just by going in and doing a slight review on how they configured their JVM, right? So every time you change versions of the JVM or change versions of your application, there's simply just a number of things that you're just going to have to go back and visit and sort of revisit the folklore and say, okay, are these things really, really justified? Is there some measurements that we can take that are going to tell us exactly how we need to tune our system? And of course, there's a version of what I call tuning by folklore, which I call tuning by Stack Overflow, right? How many people engage in that? Right. Yes, or the equivalent of tuning by Stack Overflow. And so, I mean, you end up with things like this, right? It's like, look at this. Here's our command lines. And actually, I have a blog entry on this where I took another one that's actually even more interesting than this. But there was, I don't know, something like almost 40 different switches set on the command line, right? Anybody want to venture a guess of how many of them were actually needed? 5, really close. So it was actually 6, right? So we basically got rid of about 34 different command line switches that no one had a clue why they were there or even what they were doing. I mean, so if you look at all these things here, it's like use large pages, individual allocation. Does anyone ever even heard of that? Does anyone even know what that does? Because I don't. I was looking at it going like, okay, I sort of know what large pages are. What's this individual allocation thing do, right? And there's all kinds of other things like old P-lab size. Does anyone know what that is? Okay, so I happen to know what that is. That's your promotion local allocation blocks. If you don't know what that is, don't worry about it, right? But I have no idea why anyone would decide to actually set that flag to actually now go and set the size of that particular parameter. Anyways, be that as it may, all of these wonderful flags, you can find them on Stack Overflow, and you can apply them to your JVM. And to what effect? Well, good luck with that, right? Here's another interesting situation I run into, and it's amazing how much billable I've collected by trying to tell people there's the difference between what it does and how you actually do it, right? So you'll go in, you'll do a diagnosis on a system, and they'll say, oh, but that's what it's supposed to do. I said, well, no, it's really supposed to process this thing for your customers or your users, and you're sort of confusing what it does by how it's doing it. And you get some other things, right? It's like a cache with no eviction policy, right? What do you call that? A memory leak. Exactly, right? Except for the company who happens to be selling the cache without the memory eviction policy. For them, that's a feature. Absolutely wonderful. Yeah. So sometimes these diagnoses take very short periods of time, but trying to convince people that you actually have the right diagnosis is a real problem. The only thing I can say that's helped me in that is getting really good, strong visualizations, right? A good, strong visualization of the problem generally means that, one time I had the CEO of a company who was like a complete sales droid, very nice guy and everything like that, Texan. He came in, saw this thing up on the wall like this on a chart in the projector, and he says, oh, that looks bad. You going to fix that? And all of a sudden, everybody in the room knew that that was the next thing that we were doing. It was really a game-changing diagram. Not listening to the system. So I teach a performance tuning course, and at the beginning of the course, I very unfairly, I will admit that it's very unfair, I give them a performance problem. And it's based on a game I play with some of the guys, like Dr. Heinz Kibbutz, or there's a few other people, right? We'll say, here's a minimal set of bits of information about a system. What's the problem? And we sort of play this game. It's like, what's the minimum amount of information that we can give to the other person that's still useful, but they really have to now think and plod their way through and reason out what's going on to try to figure out what's wrong with the application. So I sort of play this game with the people who come to the course. So the first thing they get hit with is this problem. And the problem is completely solvable if you know how to read the system information. And the first thing they'll do is they'll look at it and say, okay, that's all interesting. Now we need more information, right? And really, it's all there. The system is telling you why it's not performing. Go into the hardware counters, read the manuals, look at the specs as to how the technology is going to work or supposed to work. And generally, you're going to find that there's enough information there that you don't need any fancy tooling, right, except for the one here to figure out what's going on. Not being able to profile in production, right? Now, we had a nice conversation about this yesterday because yesterday they had the performance workshops. Anyone go to the performance workshops with Richard Warburton and Jean-Philippe? A couple, yes, right. And they were talking about profiling, which is really wonderful because, how profilers lie to you. Well, profiling, and the way Richard described it, it's just a statistical sampling technique. And profilers happen to apply it pretty much incorrectly, in many cases. First off, their sampling rates are way too high. Second off, as you can see, if you saw the talk yesterday, you can see that their sampling techniques are very, very inefficient, right? And if you change the sampling techniques and you actually apply proper filtering, and you get rid of the sampling bias, and you use all of the things that people taught us in statistics as to how to properly sample, we can actually find out where the bottleneck is in our system with very little overhead, right? With very few samples in our production system where it's happening. We just unfortunately can't use many of the commercial tools, which is why I generally hand roll these profilers myself to do that, because they're all like, well, you know, it's insane. First, you use safe point bias, and we have 10 millisecond sampling rates, right? So we get rid of the safe points bias, and we get rid of and we increase the sampling rate up to once a second. We do appropriate filters, so we don't get the bad samples mixed with the good samples, so we get a clean signal from the system. And then all of a sudden, you probably can do a diagnosis with 1,000 samples or less, right? Which means at a very slow sampling rate, it won't take you very long to actually figure out what is the statistically significant activity in your system. 4, and I got 3 minutes left, so it's going to go really fast, right? Diving into the code, right? We're all developers. We all know how to code. We love code. Code is great, yeah? Code is king. If we have a problem, and you're very familiar with an application, we're just going to go and jump into the code and try to fix it. And generally, what we find is that you end up fixing a lot of really ugly code that the contractor who just left wrote. But quite often, you actually don't get to the root of the problem. Number 3, give it more hardware. We've actually run into a number of applications where giving it more hardware was going to be harmful. They didn't understand where the bottleneck is. If you just came from Maurice's talk, which I did, which is why I'm a bit late, you know, he was talking about Amdahl's law and about the effects of serialization, right? So you're talking like about less than 1% serialization will knock out 4.5 cores on a 24-core machine. They're just not accessible to you, right? Adding more cores in that situation is just not a productive. It's not going to work, right? So adding more hardware to the problem or adding more memory to the problem is sometimes just not the right solution. Sometimes you need less, or you need to go and understand where the bottleneck is so that you can get rid of the bottleneck. 3, setting up a Tiger team, right? Diagnosis by committee. That works well, right? This is a really good one. And finally, 1. Poor system visibility. I would say that this is probably the number 1 problem facing teams. If teams had the right information from the right test, they would absolutely understand what the problem is. Most of the tools out there that are available today, all they do is they just basically dump tons of data into your lap, right? And then you sort of sitting there looking at it, like trying to figure out, okay, what the hell is this stuff trying to tell me? Right? And that's exactly what the state is. And, you know, that leaves people scratching their head, trying to figure out what's going on. And eventually they call me, and then we go in and try to make sense of the data that they should have collected, as opposed to all of this useless data that really isn't helpful and actually takes up a lot of hardware and extra resources in order for you to collect it and save it and process it and do whatever else it is that you want to do with it. Probably the only thing you're never going to do with it is look at it. Right? And so my time's up, and I'm just going to say that our tooling company is JClarity, and we're writing a performance diagnostic engine. Our diagnostic engine is using machine learning and other heuristics to actually, with a very light footprint, go in and really find the root cause of your performance problem, right? Without all of the data that you normally would think that you need. And sorry, my time is up, so I will have to leave it at that.